Welcome to a new test and teardown video. This time it's an oscilloscope from Philips PM3215. It's a 50 MHz, 2-channel oscilloscope, all analog, good old simple style. It's not full of all sorts of sexy features or anything. Okay, those are good. And that clickety click is also the right place. I was just playing a little bit with some of those. See? This can't be right. So I bet somebody pulled this apart and put it back together. Okay, this one is correct. At least the focus knob here is not correct. And it has something to do with a long stick that goes in there and it's not correct. I don't know if this one is working. It is from a guy with a lot of stuff that was more or less defective, all of it, so I bet this one is also defective. And it was last calibrated in 2002. I believe this scope is from the 80s, mid-80s, so it's actually quite old. I just did a little bit of Google search for this model, and if you go and look at the pictures you will find online, look at the screen. You're going to see exactly the same problem. And it has something to do with this plastic that goes over the screen. If this gets direct sunlight, it turns dark. See? And it's much darker in one side than the other one. So it's been standing at a table and the light from the window has been hitting like this angle, so it's not hitting here. And that is why. By the way, if you want to know how to clean this plastic, you have to pull real hard about here and here, and when you pull, this piece is going to come off. Then it's clicked in using those little plastic, and they sit in this little metal spring hold thing, and here on top here, this little holder here snaps in up here, right? I already cleaned this plastic as much as I could, so now it's nice and clean, but it's still this really bad color, so I just have to live with that. If I find another piece of plastic, I mean, this is very, very thin plastic and just dark bluish color, it should be very, very easy to find a new piece and just cut it with some scissors or something, right? And then change this, and then it's gonna look super nice. By the way, this is a high quality CRT, and you can see the grid is inside the glass and the back side of the glass. That reveals it's a top class CRT. So I really expect a nice and beautiful picture from this one. Well, let's power it up and see if it works. That's actually a funny thing. I always check the rear. Is the voltage correctly set? And what else can we find here? So this is a service sticker from Philips. And look at that. This unit was repaired in 82, or actually it was repaired in 81, because this one says, no, this is last repaired in the state. And up here it says free repair until another date. So the idea is there should be some sort of a warranty after a repair, but in this case they didn't fill it out. Normally if there a new error can, or is it exactly the same kind of fault, right, then it should be covered by this warranty. Of course it's difficult to prove, isn't it? Yes, there's no options or anything, but this is a battery option here, or a DC power input of so DC power input And remember to check this plus and minus here, right? So this is the opposite of what is normal, but it runs off 22 to 27 volts. That's a little bit annoying, isn't it? Let's just power it up and see what happens. So let's do the first power up. See, the power cord is just a 2-wire connection, so there's no earth in the power supply. And I don't want to kill myself, so that is why always have earth connected to chassis on odd, old, funny stuff. Because there could easily be a leak to chassis and it's going to kill you. 6 watts. Okay, 1.8 watts of idle. That is a little bit funny. But I think that leaks it has due to the DC input. So there's a switch mode converter and stuff in there, right? 28 watts. I don't see. Yes, there is illumination. There's also. Holy moly, this thing is working. What is this? Whoa, 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 this is powerful. And focus is in the middle. This is also something you really want to check. If focus is in the middle, if there's plenty of brightness, and if a normal brightness is more or less in the middle, then you know all the high voltage stuff is more or less normal. Wow, this is a super beautiful picture. It's a little bit, I don't know if that is a big issue. And 28 watts, that is definitely normal. I will play a little bit and see if it is any good. This is real sweet. 2 channels, 4 volts, and I am in 1 volt per division. So, and they calibrated both. So that means both channels measure the right amplitude, and this is 1 kilohertz. So we are in 1 millisecond per division. So that means we should have this at exactly 1 division. If I move this a little bit, it is a little bit off, tiny little bit. But I think that is within, okay, a little bit off. But it's definitely within acceptable. Let's turn this. But that is a beautiful picture. And we can of course do add, alternate or chop. Anything we like here. Oh, let's try something funny. So if we do add, we get double, right? But what if I invert one of them? Ooh, that works as well. So that should be 0. Great! All that analog stuff is working. Here is my vertical delay line test. So this is a pulse, 1 microsecond width. And look, we see the leading edge. So there's definitely a delay line in this unit. So that is fantastic. And here's, yeah, you see here it's 200 nanoseconds per division. And that is 5 divisions, so that will be 1 microsecond. So all that is perfectly fine. And as you can see here, there's plenty of brightness when you go like this, and then you just crank it up. Ooh, there's even more. This is a fast scope, remember? This is the leading edge here. Oh, we got a little bit of funny stuff here with the... Ooh dear. That contact needs a little bit of love. Okay, so let's look at the leading edge magnet. Oi, 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 oi. And what is that? So that is times 10. So that is 10 nanoseconds. Right? So this is the rise time. Let me try and move this. And then maybe focus. Yes, we can even do that. And I can even try and play a little bit with the rise time here. So I got 2 nanoseconds on my input. And now I got 10 nanoseconds on my input. So that should be one division. From 10 to 90. So yeah, it's definitely a fast scope. So here is how you open this thing. Those 2 big screws. That's the only thing you do. Don't fall for this, because that's kind of the normal thing, to hide screws under rubber feet, and that is not the thing here. Only the 2 big ones. And then you pull this out carefully. So there's a mains transformer right here, and that is, I would assume, a 24 volts or something like that, because it's also possible to run off a battery. And then I think there's a, yes, there was a little connector here. So that is the trick. Off you go. And then I think you just pull out the entire chassis in one go. This is really a beautiful scope. I am very, very impressed. It doesn't really look like a lot of people was in here and poked around or anything. So here's the tripler for the higher voltage. So you see here's the anode wire. It's of course shielded, so it's safe to touch this. It goes directly to the CRT, the anode. Nicely shielded. So that will be the horizontal deflection, and that goes in here in this corner. Vertical deflection amplifier is in here, as close as possible to the CRT. So that is a good way to make it fast, right? And then the input to the vertical amplifier is via this cable. And this is not just any cable. If you look real careful, maybe you can see it's actually 2 little wires that goes back and forward in a cross. So this is a coaxial delay line, and it goes in here and around and around and around a million times, right? So this is why you're able to see the leading edge of what you're triggering on, because that signal travels and then it's still displayed. Fantastic. And here's the switch mode power supply that makes it possible to run off a battery. See, there's only 1 power transistor and a flyback diode. Oh, no big surprise, of course it's a flyback converter. And that's actually all there is to it. What is this? And what have you got here? So that will be the 2 inputs. The attenuators, they will be down under there. See, can't really go in there and have a look, so that's a little bit, because you see, so that's a little bit disappointing. That will just be some switches in 2 or 3 sections. That is beautiful. Shielded cable. Where's that going? Ah, that is blanking. Or some stuff, right, for the deflection. Or this is the triggers. No, I don't know what that is actually. So that is different. Trick this and trick that. Only one transistor for trace rotation. Ah, no. Sorry about that. That is, of course, the illumination. Remember? So we got some bulbs in here. And then they light up the screen, and that is driven by this transistor. Obviously, that is how it works. Okay, got it. Oh, that is funny. We got the two bulbs on the top, but you could also mount two more at the bottom, but they are not here. Really? Maybe those are not needed. Made in France. And sometimes you'll be able to find a date stamp or a sticker on a CRT, but that is not the case with this one. So I'm very sure this scope is 1981 due to the repair in 1982. But when I look at the... Yes, see? 80. How is that possible? Maybe that is the chip that was replaced. Because those chips are from 80. And this looks a little bit hand soldering. We also got some fast amplifiers and stuff right here. What are we looking at here? That will be A, B, chop, add. Okay, so that will be when it comes from the two amplifiers, then it comes here, right? So that will be the signal path, and we got some NTC resistors to do temperature compensations, and that will be the time base section. That is funny. Components flying in the air. So this is trigger, yeah, external trig input. So that is of course also possible to go quite fast. Yeah, absolutely beautiful. Good solid construction. Look at that. Not this thin flimsy stuff we have seen before on all the cheap Chinese scopes. No. This is stable mechanical construction. That is what we want to see. Definitely. Yeah, okay, this is not a Tektronix or an HP or anything, but see, I can lift it with 2 fingers. But still, it's quite alright. I think I said I lie earlier in the video. Because you know what? This is actually a rectifier, a bridge rectifier, so that the incoming DC can be either positive or negative. Definitely we got rectifiers and stuff like that. So we got DC coming in here. And that will be push-pull transistors for the transformer. So this is a half bridge push-pull circuit and not a flyback. That is definitely not what it was. So I'm sorry, I was lying. That's real bad. What is that screw doing here? I think there was maybe a shield. A shielded something here, right? Because why would this look like this? That's funny, isn't it? Well, this is why I never get tired of playing with analog scopes. What the heck is it with this? See, in X deflection, Okay. Here's the fun thing. This is of course a normal time base. Here's my vertical, right? So X is my horizontal. So my horizontal is now in external. And it says here, trig or X deflection. So now you have some more funny opportunities here. You can of course keep it in here and then magnify it. If you want to do that, perfectly fine. Or you can put your input into the B channel. See, trig or X deflection. How about I click channel 2? And if I have it in channel 2, then I have all the possibilities. Oh, this pot meter here needs, see? And then I can tune it for the correct. Oh, I don't have position here. That is funny. So it's here, right? Okay. We are done. But I think that was a little bit funny. And you can also take channel A as X deflection as well. So what you see here is actually on linearity problems, because that should be a straight line, right? Yes, that is not following a straight line. And that explains the little funny things that you see sometimes, right? That is linearity problems. Why is it doing the blinky? Yeah, okay. Shutter time. So thank you very much for watching. I hope you had fun. Bye bye.